Welcome to Chapter 11, Basic Cryptography. In this chapter we're going to define cryptography, describe what a hash is, what symmetric and asymmetric cryptographic algorithms are, and we're going to talk about different ways you can use cryptography. There's a multi-level approach to information security. You're going to have firewalls, NIDs, and all-in-one security devices. The second level is how do you protect the data that's traversing those? You do it by encryption. So, fundamentally, what would you say the definition of cryptography is? Brandon? What do you think the fundamental definition of cryptography is? Simple. Cryptography just hides the data. It's pretty simple. It just scrambles the information to where it's unreadable, unusable.
Wait. That's stenography.
No, it's not
You
stenography.
said hides the data, didn't you?
It does hide the data when you make it unreadable by scrambling it. So you're hiding the data.
But hiding would mean you couldn't see it.
You can't see it. It's unreadable.
Okay, hiding would mean you wouldn't know it's there.
It's unreadable.
But you still know it's there.
Just because you know it's there doesn't mean the data's still hidden from you until you unscramble it.
But then that's going to confuse me because stenography is
No,
hiding.
stenography is completely different. Stenography actually hides that there is any data. Cryptography hides data.
I understand. Just saying the definition you're giving. Is the
Right.
same. If someone didn't hear you're speaking it, it would confuse them because they both say hide.
That's why it's on recording. Steganography uses files within files to cover up files, or you'll have a picture that a file is uploaded into. Basically, the one cool thing about steganography, I don't know if y'all have ever heard, but you can take the original file size of the picture and compare it to one that has something that has been hidden in it. The one that has the data hidden in it is actually smaller than the original one.
If it's a picture?
Yep. So that's the easy way. If you see this very high definition picture that easily would be 500 meg to a gig, okay, and you see it being 112K, I mean, it's not going to be that extreme, but still,
You drop the definition so you can hide it.
it
Make it lower quality.
it doesn't lower the quality of the original picture. It just takes bits and puts them throughout, and so the bit numbers change. So what it does is it says, all right, if I'm going to put this secret password in here, here's what the secret password is in binary. Now, here's what the original metadata is. Or you have the original metadata, and all I do is switch and put these in. So I take this number in here, image height is in here, graphic. I mean, you'll be able to tell how it's all changed. You see a bunch of zeros now that you didn't over here, right? That's why it becomes smaller file size. All it does is take this hidden image or hidden information changes in here. You'll still see the same picture, but it just changes the bits.
It changes the reserved space too.
Yep. Oh, it changes a lot of things. So, how many of you have heard of the Caesar cipher? Well, that's where cryptography first started, was with Julius Caesar. He would change text messages to give, or change not what you'd be on your phone text messaging, literally text messages, and he would change them and send them out, and you had to have some way to decode it to understand it. Encryption does that. It gives you a set of, or key, if you will, to change it. How many of y'all practiced cryptography when you were a kid? We all did, right? Where's the secret message? You know? And decryption is what you do when you take it back from the encrypted message back to the regular message. All right? Clear text data, that's something that you don't want to do. Basically all it is it's your data that is stored or transmitted via any type of medium without being encrypted. So if I said Aaron Smith was born on this date, and I gave you all his secret information, like his passwords, his hash algorithms, and
have to kill you. I'm just kidding.
I would send it to you in clear text. What's the difference between clear text and plain text? Plain text is one that already has an algorithm attached to it, just hasn't been encrypted yet. Clear text is the text itself. Yes, Aaron?
Can we set up lights that are controlled by the internet and connect them straight to the internet and see how long it takes for someone to hack into them?
I'm sure you could, since the information grid or the electric grid is already connected to the internet. All utilities are. You've heard smart grid technology? That's what it is. That's why OG&E doesn't have to send a guy out to your house to read your meters anymore. It automatically sends them in.
I'm talking about where you can turn them off and on.
You can do it from there. That's how they can remotely turn off your services. They don't have to have a guy come out there. They put it in the system, turn it on in X number of hours. Oh, we'll get to you within 24 hours. What is the key? Remember, I just talked about it. Basically, it's a set of either 1 or 2 digits, or it could be multiple digits, and it gives you the answers to what, if you see this particular one, like if you see an uppercase S, the answer is really a lowercase s. Basically, here what you got. In simple text, you have the plain text, confidential memo, layoffs at Lakeview store will begin. It gets encrypted. Now it's in ciphertext. It's transported to the user in ciphertext. They have the decryption algorithm with that key, and then they're able to read the clear text. Does that make sense?
Yeah.
Cryptography. You can provide 5 basic types of information protections. Confidentiality, integrity, and availability. Y'all all know what those mean. Authenticity, making sure that it is what it says it is, which to me, authenticity, or the authenticity of the sender, not the authenticity of the document. It says who is sending it is who they say they are, and then non-repudiation means that that individual did perform that action. All right. There are 3 category types of cryptographic algorithms. You have symmetric, asymmetric, and hash. So what is a hash algorithm? Well, it's pretty basic in itself. All you need is a unique identifier. So when you log into Microsoft, how many of you know you have a unique identifier, right? It's called a SID. That SID is what helps transform your hash, or creates your hash. And the contents cannot be used to reveal the original data set. Basically, all it does is say, here's my original password. I've got it encrypted now. So that when you type in a password, it sends that encryption value. Does it match? If it does, then you're authenticated. If it doesn't, then you don't. However, this information is incorrect. Context can be used to reveal the original data set if you have the right tools. Just takes a while. Example of hashing. Customer has a bank PIN of 93542. The number is hashed, stored in the server, and is also stored on the card's magnetic strip. User inserts the card into the ATM, puts in a PIN. If that PIN's hash matches the one that's on that card and in the server, he gets authenticated. If it does not, he will not. And simple right there. Does it match? Yes. Okay. Then we have secure hashing algorithms, which are fixed size. They have unique, they're original, and they're secure. What does the fixed size mean? They're the exact same size as the hash. Unique, two different data sets cannot produce the same hash. It's impossible. Original, the data set cannot be created to have a predefined hash. In other words, if 93542 will not always be the same hash on every computer. Does that make sense? And then secure. The resulting hash cannot be reversed to determine original plaintext. Hashing can be used to determine message integrity. Yes, Matthew?
That was my arm trying to move it. Okay.
What it means is simple. If Matthew is trying to hack the communication that I have with Kristen because he's a man in the middle, the system will know because it will have messed with the unique identifier and the hash algorithm will have been changed. Does that make sense? We call that the HMAC, or the hash to message authentication code. How many times have you seen a MD5 hash or SSH hash on websites? So when you download it, you can match it up to make sure that you got the original document. Y'all seen this before? No? Tracy, you've never seen it before from any website?
I understand the concept, but I haven't actually seen
A lot of the individuals will say, okay, I've got it hashed, so here's what the hash is, so that when you look at the value of the hash, if it doesn't match up, don't open it. Don't run it. This one was always fun. The original plain text message, you're hired, comes in a hash, gets it 540-9835. The man in the middle tries to change it to you are fired. The hash algorithm on this side comes out to be this. They don't match, so it doesn't work. It makes sense. Like, here's exactly what you would see. If I was downloading automation.exe, I could check any one of these and copy this hash just to make sure that it matched. So what does hashing do for you? All it does is validate integrity. What are the most common hash? Message digest, or the MDs. Secure hash algorithm, or SHAs. And then the other three I don't really see much anymore is Whirlpool, RIPE-MD, and password hashes. Message digest, do what?
You don't see password hashes mentioned in that?
Not that the category. I mean, you see a category of passwords that have been hashed, but not password hashing. It's usually based on MD5 or SHA. Now, as I say, I haven't seen it in a while. That does not mean that it's not there. Okay. MD has three different versions. It has MD2, which is the plain text of any length up to 100 and creates 128 bits. It also adds 128 to make it 128 bits if you have a shorter message. It's really slow and not used widely today at all. Message 4, MD4 had a lot of flaws and was not accepted very much at all. Then you have the one we use, MD5. It was designed to address all the issues of MD4. Instead of being 128 bits, now you have a 512-bit hash. Weaknesses in compression function were leading to collisions. And it's known to be one of the more secure. However, then you have SHA, which is more secure than MD. As of right now, they had not, when this was written, had not found any vulnerabilities. I'm sure there's vulnerabilities with SHA. Whirlpool is adopted by ISO and places like that. They create messages up to 512. The race integrity primitives evaluation message digest, or the RIPE-MD, have parallel chains of cryptography. And then they can get those converted. So the results are added at the end. Okay. Password hashes, yeah, they're used by NT LAN manager or LAN managers. But other than just your local logins, not really widely used. This is just for passwords, but I've seen them use them on MD5s. Linux and Apple, Mac, or Linux, Apple, and Mac strengthen password hashes by including random bit sequences. It just makes it more complex to blurry. Symmetric algorithms. DES, triple DES, AES. Y'all have heard of those, right? That's what a symmetric is. It means it has to match. They do it at the exact same time. So here's a symmetric. Comes into the encryption algorithm, changes to the ciphertext, but I'm using this key so that when it gets transmitted, they have to use the same key to undo the ciphertext to get the information. All right. Two symmetric algorithm categories. They're based on the amount of data to process time, and you basically have two different types of ciphers. You have the stream cipher and then the monoalphabetic substitution. All right. What is the stream cipher? It's pretty simple. Here's one. I'm replacing it with this. Again, if I have an uppercase S, I'm doing it with a lowercase s. Does that make sense? It's basically just a substitution cipher. Very, very easy to do. Same thing with the monoalphabetic substitution. That's very easy to break. It's your basic cryptography that you did on sheets in school. All right. The stream cipher will take THE, do it, and comes out of ciphertext as #1. So what you get is you have your plaintext letters. Your substitution letters are the ones backwards. So a profit was achieved by our ACT unit. And there you go. Y'all think y'all could have figured this out? So if I give y'all a cryptographic homework assignment, y'all think you could figure it out?
That's how complicated it is.
Well, if I do homoalphabetic, but I'm not going to give you what the substitution letters are.
You gonna?
I might. May give you a ciphertext and tell you to do it. Or we can do a transposition, where you have the determined key, you assign a number value to it, you record the plain text by row, profit was achieved by our ACT unit. So then I just come AAO, RHR, and this assigned number value would be like 1. The next one would be IVT, then you'd have FIC, then ABI. Y'all catch how that's doing that? Okay, you have Amanda sign. All right,
All the same.
Amanda sign. That's the key. So what do we have? You start with the first letter here is A. A's 1. You find the next A, then you go 2, then 3. Then what's after A? D, right? That's the next one. Now, E, F, G, H, I, J. You see how it's going now? If you have multiple of the first letter, then you read right to left. So every time you start over here, A, Oh, that's number 1. My next A, my next A. Now for number 4, I start back here because I've already got this one. Is there any B's? No. Any C's? No. Any D's? Yes. That would be D. If there was another D out here, that would be 5. Y'all catch that now? So then, in this case, there wasn't. So no D's, no E's, no F's. Got a G. G's now 5. But if there had been a G over here, that would have been 5, and this would have been G6. Does that make sense? Okay. And they just go through here. That gives you the assigned number value. Now, once you have the assigned number value, you come straight down from example 1. This would be the first 3 that you're going to do because you put everything in a box. So what you do is you say, I want 9, let's see, this is 9 characters across. So I'm going to put my box to 9 characters wide. All right? Everyone okay with that?
It's 10.
Oh yeah, there is a 0. So there's 10 digits across. So I take my first row, and I got AAO. Take number 2, RHR. Take number 3, IVT. Except they screwed that up. They put IVI. So is this a real ciphertext?
No.
It should be IVI right here. I mean
Where are they
IVT.
getting the AAO?
AAO right here. RHR. You put that as
Oh,
the
that's
next
for the
3.
ciphertext.
Uh-huh. That's where you take your plain text, you put it in here, and you create your ciphertext by you extracting by the columns. The columns of the correct assigned number value. You following along now? For homework?
Well, we have a homework assignment that's this, basically.
It's a ton of
Decrypting
it.
It's a lot.
And they're
Kinda
all
challenging.
sets of 5 letters.
Is it for computer security?
It's
No,
for
principals.
principals.
Right here.
I heard about that
We
assignment.
don't have a key.
It's simple. Go ahead. If you know that she's already said they're going to be by 5s, right?
Well, there's space in between them every 5
The
letters.
ciphertext is in
Here, I'll
5s
show you
instead of
what it
3s.
looks
Is
Oh.
what they're saying.
Okay. Then that means you have 5 rows.
Yeah.
Or if you have a blank, you may have 6 rows. Because if I run out of letters here, let's say I didn't have unit, I just have blank, 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 blank. So it looked like SY blank, WD blank.
Well, the last one is 3 letters and
Yeah,
6 rows, yeah.
and maybe 6 rows.
I'll try to write it down like that.
All right. The final step after you get the cipher, if you have a 0 and a 1, you have a 1. If you have, if they're the opposite, you're going to have a 1. The only time you'll get a 0 is if it's 0, 0, or if it's 1, 1. I mean, let me correct myself. Yeah, if it's 0, 0, 1, 1, if they're the same, you're going to get a 0. If they're different, you get a 1. And that's how you do your ciphertext. All right? Then we have the one-time pad. Basically just a random key that gets generated and built off of that is never reused. Block ciphers. Now those are fun. Works on an entire block of plain text at a time. Separate blocks of 8 to 12 bytes encrypted independently. And then when it's sent, the blocks are randomized. Stream cipher advantages. It's very fast if the plain text is short. The longer the plain text, the slower it's going to be. It's prone to more attacks because it uses the same type of stuff over and over and over. So the engine's going to be the same on how it does it. So it's easy to be reverse engineered. Does that make sense? So it covers your CIA, but not authenticity or repudiation. So what's our next step? Asymmetric encryption. Well, let's get into DES and triple DES. DES was made in 1970. Triple DES was designed to replace DES because it uses 3 rounds of encryption instead of 1. The ciphertext of the first round becomes input for the second iteration. So whatever the final key is in there is what the key is for the second. So here you go. We have the plain text, it gets converted, it has the ciphertext here, is encrypted again. This key is now for here, and notice the keys change for each one. That's triple DES. AES. It came out by the National Institute of Standards and Technologies in 2000 for the as a replacement for DES and triple DES. It is now the official government standard. Remember, we're at AES 256, right? Right. Then you have the Rivest cipher. Basically, came out by Ron Rivest. It's just another group of cipher algorithms. Then you have the IDEA, which is basically used in Europe only. Then you have Blowfish, which I know sounds really funny, but it's a block cipher with 68-bit blocks with a key that links from anywhere from 32 to 448 bits. How long do you think it's going to take to break?
Pretty long time.
What's the weakness of symmetric algorithms? Distributing and maintaining a secure single key. If I give you a key to my house, how long is it going to take before you break in?
I don't know where your house is.
But then again, does that really matter? How long is it going to be before you can break in if I'm giving you my key?
We obtain the key, not long.
Right. You just have to find my house. But if I don't give you the key, don't tell you where my house is, how long is it going to be before you break into my house?
A while.
Well, maybe not if you can go find public records in my house and just go kick in my door. But then by the time you do that, about 30 seconds later, the police will be there. So
Yeah, 30 seconds, sure.
by the time you break into my front door, it will be.
The frames? Because usually the weakest part even on a strong door is the frames. Just keep
I have
the
a steel
frames.
frame.
Oh, the frame is steel too? Is somebody paranoid?
My wife.
Fair enough.
Just go through the window.
Yeah, break the window.
My motion detectors catch you.
Yeah, but it's
Outside.
for the police to get there.
No, not when they patrol my street about 10 times a day.
Where do you live?
I live about 500 blocks, if you will. You know, you have your 100, 200, 300, 400, 500. So
For
I
5 blocks.
essentially 5 blocks south of the highest crime rate area in the city of Midwest City. So that's why we have all those protections. And you're monitored from the time you step foot on my property. I've got cameras and hidden cameras and everything. So,
Move faster.
So I'm just gonna go.
like I said, once it triggers it, good luck. My new house, I'm going to actually put the little lasers about a foot up off the ground. And if you break that in the middle of the night, you know, it'll start taking motion pictures of you. It'll wake me up, and if I see that you're an intruder, then I just hit the police button. They'll be out there by the time you get to my front door, or trying to break into my front door. That's going to be on our new house. I can't do it on this property because I've got federal right of way every which way in my yard, so I can't really stick anything in there. But it's pretty interesting. Asymmetric. That just means I have 2 keys, right? What are the 2 different types of keys, Tracy? Public and private. So I take my public key, send it over here, and out in is Bob's. I use your public key, Tracy, to send it to you. You then are like, okay, I'm going to use my private key to decrypt it. That's all it is. Digital signature does basically the exact same thing. It hashes it, gives me a hash code. The hash code helps me develop, with the private key, the digital signature that gets added into it. Encryption algorithm. Now, I don't know why they didn't do this because it should have been encrypted right here, which we encrypted it. Then it comes over here, finds the hash for the digital signature, after it's been decrypted, the hash is matched, then you're good. Does that make sense? Shall I say that again? I write up a Word document. I then put a hash on it, an MD5 hash. I then take my private key to lock it. I send it over to Tracy, who opens or decrypts it with my public key, then reads the hash value that she has after she undoes the hash to validate that the message was truly sent to her. Does that make sense? And here's the short and simple of it. If I want to send a encrypted message to her, I use her keys. If Alice wants to read it, she has to use her private key. I want to send a copy of myself with the message that I sent. I have to use my key. I use my public key to encrypt it, my private key to decrypt it. If I receive a message from Alice, I will open it with my private key. If I want to send it over to Susan so Susan can read it, then I encrypt it with Susan's public key. If I want to send Alice a message with a digital signature, I use my private key, and she opens it with my public key. Does that make sense? Whatever the person receiving it will always open it with the opposite key of what it was sent in. Does that clarify cryptography for you?
Say again.
If I send it with my public key, if I send it with my private key, you will open it with your public. Or my public, I'm sorry. If I send something to you in your public, you open it with your private. You always open it with the opposite key of what it was sent in. And I can never send Tracy something with her private key to her open it on her public key. Why is that?
You could never send something.
With your private key to you,
You should never have my private key.
exactly. If I got your private key, then anyone can read it.
Yeah. That's how to change.
And that's why asymmetric is really the perfect way of doing it. Some of the best ones are RSA. Then you have the ECC, or the elliptic curve cryptography. So you just find you a spot there and figure out where along this line you're going to be. Make a design and find from point to point, and there you go. Quantum cryptography, then that goes all the way down to the photon level, the microscopic areas. And then InTrueCrypt, basically, is the fastest encryption we have. It's lattice base. There's an example of lattice base. So, when we use cryptography, what should we use it for, Aaron? Everything. One, Matthew.
Any data we don't want people to see.
Well, what do you mean by people?
He doesn't want you to see his pictures, so he's not going to send them to you. If he does, he's going to put it in a cryptographic message so you can't decrypt it.
Is the confidentiality aspect, right? Of CIA, and there's the integrity too, but
And non-repudiation. But you have a lot of different reasons, depending on how he wants to do it. How secure do you want this data? So if we do it through software, how many are you going to use PGP? Pretty good privacy.
pretty good.
Anyone in here going to use pretty good privacy? You do and you don't know it.
Yeah, say you do.
If you do it on Windows, you do. What about GPG? All they are is symmetric and asymmetric cryptography. Then we now have EFS, which is a lot better than PGP, right? Y'all awake? Didn't think so. How many of you have heard of BitLocker? It is based on EFS. Okay? It's what locks you out unless you have permissions to see the file. Hardware encryption. Software encryption can be subject to attacks just because it can be hit. What about hardware though? What do y'all think? USB device encryptions? Y'all didn't think about that, did you? Are TPMs, trusted platform modules?
I was gonna say, if you link a motherboard to a hard drive, you switch it to another computer, it gets mad and won't even start.
BitLocker.
I used to have to deal with that.
HSM, hardware security module. Any questions? Y'all's brains fried?
Nah.
Right, just
Where I
slow
used to
dish.
work, I'd have to unlock the BIOS and these laptops because the BIOS wouldn't work without the hard drive. That was painful. Unless
Mhm.
someone locked it too, and that hard drive wouldn't work without that, so it was annoying.
I understand.